So in our last lesson, we talked about what a function is. In Objective 2, we're going to talk about function notation and how to use that. So before we do that, let's go through some of these reviews. And I want you to try some of these on your own. It says, is the relation a function? Explain why or why not. So I want you to try numbers 1 through 3 on your own. Go ahead and pause the video and try those out. Alright, so hopefully you paused the video and tried some of these out. These should be a review from your last lesson. So the first one is not a function. Remember, if you have the same input going to two different outputs, right, this 2 is going to the negative 17 and also the 20, right, that is not going to be a function. Remember back to our vending machine example. If I put a 2 in, if I input a 2, I don't know if I'm getting a negative 17 or a 20 out. So that is not a function. I did not explain my work here. Make sure you have an explanation for that. For number 2, that one is good because all of my inputs are different. So since all the inputs are different, that is a function. For number 3, that's a graph, and I use the vertical line test to figure this one out. Because it does not pass the vertical line test, that one is not a function. Remember, you can also write out some of these coordinates to figure this out. This coordinate right here, this first one, 1, 2, 3, 4, is 4, 1. The one above it is 4, 3, right? If I have the same input going to two different outputs, this is not a function. That's another way to tell for a graph. So hopefully that was just a bit of a review there. We're going to move into what's called function notation next. So since functions are rules that converts inputs, so x values, into outputs, which are usually our y values, it makes sense that we have a notation to indicate what this rule is. So what the input is and what the output is. So we're going to review this, what's called function notation. So function notation always has this f of x. How I read that is f of x. So function notation, it looks like a parentheses, right? But how I read that is f of x, a function of x. Okay, so functions always have this specific notation. Sometimes you'll see it with a g. How I'd read that would be g of x, right? When it has those parentheses in there, that's what that means. Basically what you're doing is your input is going to go in this parentheses here, and it's going to output whatever it gives you, right? So function notation, how I read it is going to be the function of x, or f of x. And I'm going to be saying that quite a bit throughout these notes, so you'll get the hang of it pretty quick. Let's look at A. So for each of the following functions, find the outputs for the given inputs. So I'm going to scroll down and zoom in a little bit. Looking at example A, it says the function of x, or f of x, remember again I read this as f of x, is 3x plus 7. So what you'll notice is I have a number here. I want to find f of 2. So what I do with that is I plug it in for my x. And that makes sense because basically what I'm doing here is I'm replacing this x inside the parentheses with the 2, which means I just need to plug in the 2 for the x. And all I'm doing here now is just solving this out. Pretty easy. We've done this before in the getting ready for equations unit. So 3 times 2 is going to be 6. 6 plus 7 is going to give me a 13. So my final answer would be f of 2 equals 13. For the next example, f of negative 3, I'm going to use a different color. I again want to plug in negative 3 for my x. So instead of the x, I'm going to plug in negative 3, and now I'm just going to solve. 3 times negative 3 is negative 9. Negative 9 plus 7 is going to give me a negative 2. So my final answer, f of negative 3 equals negative 2. So I'm plugging in the x and getting out my y. Plugging in the input, getting out my output. Very similar, like I said, to what we did back in the Getting Ready for Equations unit. This is just a different way to write it, right? Function notation looks a little different. So that number inside the parentheses, looking at example 2, is going to be our x value. So looking here, our x value that it gives us is 20 for our first example. So if I want to find g of 20, I'm going to plug that 20 in, 20 minus 6 over 2. So I'm plugging that in for the x, and then I'm solving for that. 20 minus 6 is going to give us 14 over 2, which is 7. So my final answer, g of 20 equals 7. Let's look at our next example, g of 0. So for this one, I want to plug in 0 for my x and solve for my y. Solve that function out. I'm plugging in the input of 0 and getting out my output. 0 minus 6 is going to be negative 6 over 2, which gives me a negative 3. So I know g of 0 equals negative 3. Again, it looks a little different. This is function notation, but basically all you're doing is plugging in your x and then solving it out. Let's do one more example together. Looking at example C, I want to plug in the 4, right, because my x value here it gives me is 4, and solve it out. So I have 2 times 4 plus 1. Well, what's 2 times 4? That's just going to be 8 plus 1. Well, what's 8 plus 1? That's just going to give me the square root of 9. What that basically means, the square root of 9, is what number times itself equals 9? That's just going to be 3. So my final answer, h of 4, equals 3. All right, our last example here. I have h of 0, so I'm plugging in 0 now. So I have the square root of 2 times 0 plus 1. Well, 2 times 0 is just going to be 0 plus 1, which is just 1. The square root of 1 is just 1. So my final answer would be h of 0 equals 1. Here we go. All right, so hopefully you noticed I was saying how I was reading each of these is g of x, h of x, h of 0, right? So function notation, you always read right here like this. So I'm highlighting this right now. F of x. That's kind of how you're always going to be reading it. All right, so what I want you to do right now is the your turns. Try numbers 1 and 2. Kind of look back at our examples, but all you're really doing is you're taking that number inside parentheses and you're plugging it in for x. So go ahead and pause the video right now and try out numbers 1 and 2. All right, so hopefully you paused the video and tried these out. So you should see my work for number 1. I'm just plugging in negative 117 for the x and then solving it out. Negative 117 divided by 3, I get negative 39 plus 10. My final answer is negative 29. For example 2, I didn't write all that out because it is a little harder, right? For that one, I'm still plugging in the negative 7 for my x, right? I have f of negative 7. However, in this problem, you should see I have 2 x's. I have one here and one here. So I have to plug it in for both of those and solve it out. So when I'm solving this guy out, I have f times 5 times negative 7, 5 times negative 7 is negative 35. Negative 7 squared, well, negative 7 times negative 7 is going to be a positive 49. And then I just add these up, negative 35 plus 49, and I do get 14 here. So my final answer, f of negative 7, would give me 14. Again, so for those, I'm just plugging in my value for x and getting out my output of y. All right, so I already kind of mentioned this, but function notation can be very confusing, right? Because it looks like it's multiplication due to the parentheses, but there's no multiplication involved, right? This notation serves two purposes. It tells us what the rule is, that's purpose one, right? And it also is to specify an output for a given input, right? So our output is y, our input is going to be x, right? And our function notation is always going to look like this. Y equals f of x. All right. So given the function f of x equals x over 3 plus 7, do the following. So part A says explain what the function rule does to convert an input into an output. So we want to explain what steps are happening here. Well, let's kind of go step by step. Converting our input to our output. So our input's x. So our first step is we divide the input by 3. Once we're done with that, we add 7 to the result. So first we divide that input by 3, and then we're adding 7 to the result. That's kind of the rule we're following here. All right, so now let's try to actually evaluate f of 6 and f of negative 9. We've already done this. So part B, I want you to try to pause the video right now and try to do that on your own. Okay, so hopefully you tried those both out on your own. So we're plugging in the value of 6 for x, and once we do that, we get 6 over 3 plus 7. Once we simplify, we should get 9 for the first one. And then if we want to find f of negative 9, we just want to plug in negative 9 for x, solve it out, and we should get 4 as our answer. All right, so hopefully you tried those on your own. Checking your answers, we should get 9 and 4. All right, let's try C. Find the input for which f of x equals 13. So what you should notice here is I'm not plugging in a number for x, right? I don't have a number inside the parentheses here. That's what I'm trying to find. I'm trying to find my x, I'm trying to find the input, but this time I know my output. My output is 13, right? So it's kind of the opposite. I'm giving you the output and you're trying to find the input. So let's go back to our function. We know our function f of x equals x over 3 plus 7. So for this one, I'm giving you f of x equals 13. So you want to plug that in for f of x, the whole thing. So I'm going to set up the equation 13 equals x over 3 plus 7. So I'm plugging in for the f of x, and I'm solving now for the x. Okay, so when I do this, we're just solving a basic equation now. So I want to subtract 7 from each side. I get x over 3 equals 6. And then I'm going to multiply both sides by 3. And I do get x is equal to 18. So for this one, I'm just working backwards, right? Instead of giving you the value of x, the input, now I'm giving you the value of f of x, which is the output, and you're trying to solve for the input. So you're kind of just working backwards for this one. All right. Let's look at example 3. All right, boiling water at 212 degrees Fahrenheit is left in a room that is at 65 degrees Fahrenheit and begins to cool. Temperature readings are taken each hour and are given in the table below. In this scenario, the temperature T is a function of the number of hours. So in this example, our input is the hours and our output is the temperature. Right? For each hour that goes past, that temperature you should see is decreasing. All right, let's look at our questions that are being asked here. So our first question is asking us to evaluate T of 2 and T of 6. Well, all we have to do here is just look at our table. T of 2, right, when our input is 2 hours, our output is 104 degrees Fahrenheit. So T of 2 equals 104 degrees Fahrenheit. T of 6, let's look where that is. That is right here. That's 68 degrees Fahrenheit. So, right, the more hours that go by, the lower the temperature is. The next question, question B, is asking for which value of H is T of H equal to 76. So for this one, I am working backwards. All right, so I want to look at the temperature. Where is the temperature 76 degrees? Well, I see that right here. So T of H equals 76 degrees when H is equal to 4 hours. So that one I'm kind of working backwards. I'm giving you the output and you're trying to find that input. Question C is asking between what two consecutive hours will T of H equal 100? Right, so again for this one, I want to look at the temperature, the output. It's asking for between what two consecutive hours will T of H be 100? So you should notice I have 104 degrees here at 2 hours and 85 degrees at 3 hours. So I know between 2 and 3 hours, the temperature will be 100 degrees, right? How I arrived at that answer, basically what I did is I just looked at the temperature, right? It's decreasing, so I know it has to be between 2 and 3 hours because that's where the temperature is between 104 degrees and 85 degrees, all right? So I want you to explain that answer on your own right now. I kind of verbally explained it, but I want you to write that down, and then we're going to move on to exercise 4. So pause the video if you need to, but I want you to write your explanation here, and then we're going to move on to exercise 4. All right, so the last thing we're going to really talk about in this video is function notations when we use a graph, right? So we talked about equations, we talked about tables, and now we're going to move on to function notation using a graph. So in exercise 4, it states the function y equals f of x is defined by a graph shown below. It is known as a piecewise linear function because it's made up of straight line segments. Answer the following questions based on this graph. So piecewise linear functions, we're not really going to talk about much this year, but basically there's different pieces, right, that make up this function. Okay, so let's talk more about part A. So we're trying to find f of 1. So that's what's asking us to find here, f of 1. Remember back to what that means. That means our input value, our x value, is 1. So I want to look on the graph. Our x value of 1, right, x is 1, going to be right here on the graph. So what is the y value when x is equal to 1? Well, let's kind of map this out. So at x equals 1, our y value is going to be at, if you count up, 4. Right, so I'm looking where x is 1, our y value is 4 for that one. Let's use a different color for the second one. We're looking at f of negative 3 here. So again, that is my x value I want to look at. So I'm going to go all the way back to negative 3. That's right here. And I want to look at what my y value is at that point. So at that point, my y value is going to be at negative 4. So that would be my answer there. So I kind of look at what's my x value and then map it back over to find my y value. Let's look at our next one, f of 5. So I'm going to count all the way where x is 5, 1, 2, 3, 4, 5, so right here. And then I want to figure out what is my y value at that point. My y value is just going to be at -2. And then my last one I'm looking at is f of 0. So for that one, when x is 0, right, my y value is just going to be right here, and that is at 2. Okay, so for each of these, the one inside the parentheses is my x, so I look over to where that x value exists, and then I find what my y value is there. Okay, so example B is going to be slightly different, right? So make sure you have those down. I'm going to erase the board, and then we're going to look at example B. All right, so it says solve each of the following for the values of the input that make them true. So for this one, I want to find the x value if I know my output or my y value is 0, right? F of x equals 0, that's basically the y value. So let's look on our graph, and there might be more than one answer for this. I want to look where y is 0. So I'm going to highlight this here. Y is 0 right here, right? So y is going to be 0 right there. So where is this true? What is our x value at each of these? So it crosses here, here, and here. All right, so the x value that makes this statement true would be -1, right? It would also be at 1, 2, 3, 4, and it would also be at 7. So there's actually 3 x values that make this true, right? Let's try the next one. This is a little bit harder. I want to find f of x, where f of x equals 2. So for that one, I'm going to highlight where y is 2. I'm going to use a red color here. Okay, well, where does it cross the graph? Let's make dots there. So it crosses right here and right here. So that would be where x is equal to 0, and also where x is equal to 3. So this one has 2 answers, right? So we want to look at, for part B, where our y value is, and then look back to see what x values are there. Okay, so we're kind of working backwards. All right, so I'm going to erase the board, so make sure you have that down, and then we're going to move on to C. All right, part C says, what is the largest output achieved by this function? And at what x value is it hit? So our output, remember, is our y values. So it's looking for the largest output. The largest output basically means the biggest y value. So I want to look for the biggest y value. On a graph, think about it, y is the up and down part, right? So if I want the biggest y value, I basically want just the tallest part of this graph, which is going to be right here. Okay, so what is the largest output? That's at 4, right? 1, 2, 3, 4, yep. Okay, so our largest output is at 4. And at what x value is that hit? Let's look back. That's at x is equal to 1. Right? So our coordinate kind of would be at 1, 4 if you want to write it as a coordinate. So at our input of x is equal to 1, we get the largest value of y, which is at 4. All right, so we're going to be analyzing functions a lot more later this unit, but this should be a good preview of that right now, using some function notation. So I want you to try that your turn, this last one, on your own right now. Use the example if you need to help you out, but basically you just want to find all those values of g of x on the graph. All right, so go ahead and pause the video right now, try those out, and then we'll go through them really quickly in just a minute. All right, really quickly, let's go over these. The first one, g of negative 2. That one, if you see on the graph right here, g of negative 2, that's when our x value is negative 2. Our y value is going to be negative 3 for that one. If we're looking at the next one, g of 3, again, I want to look for where x is equal to 3. Well, what is our y value there? That's just going to be at 4. And then g of 0 is at negative 3, and then g of 7 is at 0. So for all of these, I'm giving you the x value. That's our x value, right? I'm giving you inside the parentheses. That's our input. And you're trying to find what y value comes out when you look at the graph. All right? So this is it for functions, using function notation. So remember back when I was talking about function notation, that's that rule, right? I say it as f of x. The thing inside the parentheses are input. That's our x value. And f of x, right, is going to be our output, or our y value. Okay, so all those are kind of interchangeable. All right. Until next time, we're going to be talking about domain and range. So go ahead and try that choice activity and the objective quiz, and then we'll move on to domain and range next.